So I don't have any slides today. I'm going to be reading off notes on my phone, so I apologize if I'm not making enough eye contact here. But yeah, Yammer is the enterprise social network. We were recently acquired by Microsoft. So I'm going to talk a little bit about that transition from being a small startup to being a larger company and how you can be intentional about organizational design so that as you grow, you don't lose those things that are special about being a startup. I'm probably going to be the most contrarian of the speakers today because I want to encourage you to think differently, both about your jobs as CTOs and about how engineering can be organized and what you can demand out of engineers. This is going to be pretty high level. I'm going to skip a lot of detail, but if there's anything you're curious about in the Q&A, I'm also going to stick around as long as I can today. So I'll start with some background. For the first few years at Yammer, we were really heads down. We were focused on building the product itself, and we weren't thinking a lot about the organization. And then we started to notice the normal thing that everybody does when you hire engineers. The marginal increase in productivity that you get for every new engineer decreases over time because of a lot of the overhead you have. Meanwhile, the world had noticed that Yammer was on to something that looked like it might be a successful business. Startups started to launch to compete with us, and large established companies launched directly competing products. So we thought there was this existential risk. We assumed there'd be a single dominant company in the space, and that if we weren't the fastest company, that wouldn't be us, and we'd essentially lose. We realized really early that small teams ship faster. Everybody knows this. The Mythical Man Month talks about how the communications overhead is a piece of this. So the challenge for us was to make sure that work always happened in small teams, and most importantly, that those small teams not be blocked on anything external to them. This is where we found real innovation in this. It's easy to organize around small teams, but if those teams are blocked on external things, you essentially just have a small group of people that are part of a larger team. So I joined in 2008. At the time, we had 2 full-time engineers that had mostly built out the original spec for what Yammer was going to be. But then the iteration started. Everybody knows that modern web applications need to constantly change. In 2008, Facebook was beating MySpace by doing that very, very well. So how it would work in the early days is that with the 3 of us, a feature would get split up based on kind of our specialization. But we weren't rigid about this. So I wasn't much of a Rails engineer when we started the project. So I was kind of learning it as I went. But if there was a lot of Rails work to do, I'd dive in. So it was good to have a small group of people who were working very closely together and not rigidly siloed, but still had specialization. So if different problems demanded different expertise, you had a diversity of experience on the team. This was pretty effective. But as we grew, because we weren't intentional about organizational design, these specializations started to become teams of their own. And they were smaller teams at first, but these teams had very similar expertise. So we had a Rails team, for example. We had a front-end team. We had sort of a back-end team. They didn't have a diverse skill set, and they were siloed. By 2010, we were up from about 3 engineers working on features to roughly 30. So were we 10 times faster? No, of course not. So why not? A lot of you are engineers, so I assume a lot of you are familiar with Amdahl's law from parallel computing. If you're not, it's a mathematical model that shows that the speed up you'll get from parallelizing parts of a serial computation is constrained by the amount of that computation that remains serial. So for example, if you have a computation and you can only parallelize 50% of it, you could throw 100 processors at it, and you're just going to get very close to a 2x speed up. If you throw another 100 processors at it, you're just going to get slightly closer to 2x. You're spending a fixed amount of time in that serial half of the computation. I'll get back to this, but a mistake that everybody makes is assuming that software engineering is just writing code to a spec. But it's not. Throughout my career, I barely remember any code I wrote. What I remember is the decisions I made about engineering, because that was really the hard part and the part that took the most time. And nobody builds engineering organizations with this in mind, or at least it's not very common. They think that it's engineering management's job, or as we heard earlier, engineers who have leveled up into higher sort of engineering ranks to make engineering decisions. I think that's a really expensive mistake. So if you imagine a typical large or mid-sized engineering org chart, you might have a front-end team, a back-end team, maybe a middleware team. Those teams own code bases, and each has a manager. Those managers report up to some boss, and there might be more layers in here if you're a very large company. The point is that that organization usually matches the code's architecture. So when it comes time to doing work, the engineers, the managers at the highest level sort of have to make engineering decisions about what's to be built before they can even break up and delegate the work. Because you have to figure out what's the back-end team going to do and how does that interface with the front-end team. So meanwhile, what are the engineers doing? They're blocked on that serial part of the process. As a side note, engineers will always use their sort of autonomy and creative decision-making for things. If you don't build it in your organization, they'll use it on things like open source projects, pet internal projects that might not move your business forward, blogs, or working on their Burning Man art cars, because they have autonomy there. If you've broken up work in the way I described, where the top-level managers have to divide tasks and then delegate them, if an individual contributor at the level of actually implementing the code spots something that's wrong with the spec or the design, they have to propose a change all the way up the org chart, and that has to filter its way back down, and that's a blocking process. Meanwhile, the other engineers in other parts of the organization will see this as churn. They're not working closely with the engineer who proposed the change, so they don't understand the rationale behind the change itself. So they get frustrated. They think the management basically doesn't get it. So at Yammer, we said, screw all that. Let's do it differently. We wanted to minimize the serial parts of the process, and this requires trust. At a conference like this, someone will inevitably tell you to hire people who are better and smarter than you. So if you're actually doing that, you can trust these people to make the kinds of decisions that would normally block on you. I think it's your job as a CTO to build and nurture the organization, and the transition from writing code to doing this, or even making engineering decisions, to focusing exclusively on the organization probably needs to happen a lot sooner than you think. I don't think you should be building a product. I think you should be building an organization that builds a product. And you shouldn't just trust managers with engineering decisions. You should delegate these things all the way down to individual contributors. If management is making engineering decisions as you grow past maybe 30, 40 people, that should be a red flag for you. Sometimes it's necessary, but that should be something you seek to avoid. At Yammer, we have a pretty good system for doing this, but it's not without its flaws. And the important part is that we think of this also as something we need to be iterating on in the same way that we iterate on our product. It's never going to be perfect, but we can just incrementally improve it over time and get a better organization as we go. All of the management layers we have this deeply ingrained in them, that their job is to incrementally improve our organization. So let's talk a little bit about how we build features. So all of our features are intended to move one of three core metrics, sometimes multiple core metrics. These metrics are virality, engagement, and monetization. It's our ability to attract, retain, and sell to customers. If you're not doing those things, you're just changing the product. You're not improving it. These core metrics allow us to measure and validate changes we release through A/B testing, but it also gives transparency to the engineers who are going to be building the feature so that they can be trusted to make these decisions because they'll have the right end goal in mind. So a product manager will come up with an idea and write a spec to it. And that's sort of a misnomer in our organization because we don't think it's a rigid specification of what's to be built. It's kind of a starting point for a cross-functional team that will assemble around this idea and fully flesh it out. Too much text in one of these is a red flag for us. It's important to us that it not be overly prescriptive or detailed. And part of why this is so important to us is we want all of the engineers who are working on it to understand the decision-making that went into the feature, but also to feel like they have ownership with the decisions that went into what they have to implement in code. So the scope of work for our projects is typically, this is our rule of thumb, 2 to 10 people, 2 to 10 weeks. We don't do any projects that are larger or more complicated than that because anything we have done larger than that ends up with this really painful crunch time at the end. I think there's a non-linear relationship between the complexity of a project and the wrap-up or integration phase at the end. So if you grow just a little bit beyond, and the sweet spot in your organization may be different from ours, but for us, if it goes anywhere beyond 10 weeks, we find that the percentage of time in the wrap-up phase is disproportionate relative to other projects. It also forces us to release often, test our assumptions, and not overinvest in mistakes. So this is that lean startup mentality. I think if you're going to try to do that, you have to codify it in your organization. It also helps with urgency. There's a subtle psychology of long projects that I've noticed. Engineers often lose track of the goal when they're working on a very long software project. They kind of think their job is to come in every day and write code, and if they're doing that, they're succeeding. They're not really moving very close to the goal. So I have an analogy for hiking. In the beginning, you're sort of really, you're fresh, you're really excited about the hike, you're moving very quickly. Then as your body starts to get tired in the middle and you can't see either where you started or where you're going, it takes a lot of mental will just to force yourself to keep moving. And I think a lot of our organizations put engineers in that middle phase for the majority of their job. But towards the end, you start to see the end of the trail, you get excited, hey, I'm moving there. Every step you take is clearly moving your goal closer to you, and you can kind of measure your progress and see it visually. So I think it's important to keep engineers kind of in that state, where they're moving clearly towards a goal they can see. So 2 to 10 people, 2 to 10 weeks, for us, keeps that destination always in sight, keeps up urgency and morale. So Yammer's org chart is broken into areas of expertise, not code ownership. I think that creating code ownership, and this is something I don't have a lot of time to talk in great depth about, but I think that making your organization organized in such a way that people own code bases creates a lot of perverse incentives that you want to avoid. I have an example from my own career where I built a really interesting business rules engine that I was super proud of. And every next project, I would try to figure out a way to build that on top of my rules engine, because that to me was like really cool. And depending on how cynical your worldview, I either created a cognitive bias for myself that constrained my thinking to the sorts of problems that could be solved by this awesome code I had written, or I just very cynically pushed my own code to raise my stature in the company. I'm actually not sure which one it was. But the point is that code became as important to me as moving the business forward. Engineers are really smart and self-motivated, and if you get them aligned with your business goals, they'll do amazing things, even autonomously, without a lot of oversight. So at Yammer, our teams are pools of domain experts, not owners of code. We've got a front-end team, a Rails team, a mobile team. This will vary based on your organization. We've even changed it over the years. But the important thing to remember here is that work does not happen in these teams. So when it comes time to doing work, we have to figure out what will the team look like that actually does the work. So the first thing we'll do is we'll look over one of these specs and try to estimate the amount of effort that needs to go into it. So if you imagine, we'll use an example feature here, we'll call it feature X. We'll say it's part of our sign-up flow, and it's intended to increase virality by providing an alternate way to invite people as you're signing up. So for example, we might look at this spec and say, it's pretty UI heavy, we'll probably need 2 front-end people, and we're changing some of the sign-up flow, so we'll need somebody from the Rails team to change some of the controller endpoints. So the product team will agree on a priority for this, and then we just wait for any 2 engineers, any 2 front-end engineers, and any 1 Rails engineer to free up, and we assign them to this project. We actually have a big physical whiteboard, we call it the big board. It's got a grid overlaid on it. We write the names of the projects down one side, and we have these magnetic tags that represent the names of all of the engineers who work on features. Every engineer actually has 2 tags. One says current, one says future. But there's a physical constraint here where an engineer can only be assigned to 1 project at a time. And this complete 100% focus on a project has been really, really key to our velocity. Everybody knows the expensive part of context switching, but nobody builds that into their organization as a constraint. With total focus, you build one thing, you ship it, and you move on to something else, which may be completely unrelated and usually is. So a lot of people ask me, what about maintenance and bugs? How do you deal with that? We have a cross-functional team built in the same way as our project teams, where we assemble members of the Rails team, the front-end team, the mobile team. We put them all together and say, your job is to handle all the incoming bugs, work down some technical debt we have, and just kind of reason about the best way to support our code in production. It's a temporary cross-functional team. I mean, there's always a support team, but people rotate on and off of this team. All engineers eventually have a stint or multiple stints on the support team. Again, it's 2 to 10 weeks. This has allowed us to deal with support in a way that doesn't block feature engineering, and also in a way that doesn't create a second class of engineer. So we don't just take a bunch of junior engineers and say, hey, you deal with bugs. We want senior engineers on this team because in fixing bugs, you want people to be able to fix the root cause of problems, not just I did enough to make this ticket go away. You want them to feel empowered to refactor code. And if they're the senior engineers who built a lot of this code, they'll have that. You also want a feedback loop between the people who are building features and the people who are fixing bugs, because the frequency and type of bugs that people see helps to inform decisions they make about product engineering in the future. So back to the big board, the other important thing it does for us is provide transparency around priorities. Every single engineering development resource is accounted for on the big board. Our CEO can walk by and say, this is what engineering is doing. And this cut down on a lot of conversation we used to have about, well, why can't we do this right now? It's because all these people are working on this. But it also allows us to say, hey, that project's actually not important. Let's scrap that, take those engineers and staff these 3 other projects I see that are waiting for people. We generally don't do that, though, scrap projects, because we have such a fast project turnover, 2 to 10 weeks, that generally we won't start on something and then later decide it's not important. The timeframes are small enough that we get good turnover there. Let's see, so on each of these projects, one of the engineers will be named a tech lead. This is the most important role in all of engineering. It allows us to decentralize management and still have accountability. So the managers are not at all involved with any of the engineering projects that are going. One engineer, one individual contributor on the project is named the tech lead, and they have the accountability for all the implementation decisions, making sure that the team is correctly prioritizing the work they're doing to deliver that one feature. And everybody also gets a chance at being tech lead. We don't have any engineers in our organization that we wouldn't trust to be a tech lead. This also helps with the code that people write. Smart people make better decisions with more context. And if you have engineers that only ever have to write code, their code will suffer because it doesn't have a lot of context. These teams have complete autonomy to touch any code, decide on any implementation, and use any technology they want. This is where I lose a lot of people. We think it's important to give engineers complete autonomy and to trust decision making. It's how you can scale throughput with headcount. If you have to constrain on the few people in your organization you trust, you're not going to go very fast. Let's see. I'm cutting some things out because I'm running low on time here. The teams also work closely with the product manager, who becomes a member of that cross-functional team, to cut scope out of the spec when it's not critical to moving the metrics that we talked about. So, for example, you might look at a mock-up and say, hey, this UI control here is really cool, but I don't think it's actually important to virality, which is the goal of this project, or engagement, or monetization, and it's going to take me 2 or 3 weeks to build this cool thing you mocked up. The PM can then say, you know what, you're right, that's not important, let's cut that out, or no, I disagree, this is absolutely critical to the feature. But having that back and forth where engineers are free to say, maybe we shouldn't build this, is really important. A lot of organizations don't build that flexibility in and end up building a lot of things they don't need to build, and it's a huge inefficiency. So in conclusion, the mechanics of our process are actually pretty simple. We have autonomous cross-functional teams of 2 to 10 people that work for 2 to 10 weeks. Each has an assigned tech lead and a dedicated project manager working really closely together. There's 1 project per person at any given time. Nobody's ever working on more than one thing. And we have a big board that makes all the staffing and priorities transparent. But there's no value in following that formula unless you really internalize the core values that drove the creation of this process. So we started with the assumption that engineering exists to iteratively improve the product, and that engineering grows in order to do that faster. You can't have this top-level focus on velocity without decentralizing your decision-making. Decentralization requires trust. You need to let go of engineers who can't be trusted. If there's anybody on your team who you wouldn't trust to push code to production without a code review, you probably shouldn't have them on your team, because that code review is just going to take cycles away from somebody who could be pushing code. I hope this also changes the way you think about hiring. I don't think coding skill alone is enough to be an effective engineer in a modern engineering organization. We heard some people talk about that earlier. If you have engineers that are good to work with, that have good communication skills, that have good priorities, who don't constantly argue with kind of your stated business goals, everybody's going to be happier. And then you can empower all these people because you can trust them. And this will create what Daniel Pink calls drive, or what W. Edwards Deming calls intrinsic motivation. Smart people will do smart things effectively because you've empowered them to. I think job satisfaction is so deeply tied to organizational trust that it can't possibly be overstated. So I think your job is to grow your company by not doing work or even managing the work being done, but to manage the organization that creates that sort of environment in which really good work can be done. You need to be intentional about how you organize, and I don't think you should fall into the lazy trap of organizing around your code's architecture. You should organize around work. Don't limit your engineers' effectiveness by failing to give them agency. Trust them to make as many decisions as possible, and codify that trust into your process. And then make sure it reflects and reinforces your values and creates the right incentives in people. And provides constancy of purpose. That's really important. Everybody should be able to sort of evaluate every decision you're making based on some high-level goal. At Yammer, it's always been velocity. If we're making an engineering decision, will it make us faster in the long run? Your business may have a different goal. For us, we're trying to define a new space of software, so we had to go very, very quickly and iterate on features. So I guess the top-level summary is organize around the work you'll be doing and trust the people that will be doing it. Cool. Thanks, everybody.
Awesome.
Okay.